In this discussion, we will take up bending of a cyclist on a level road who's trying to take a turn. It's a horizontal plane in which the cyclist is trying to move in a circular path. So when a cyclist or any rider, two-wheeler rider, tries to take a circular turn on a level road, there must be a bending happening for the cyclist with the vertical. Now here that bending is shown as angle theta over there. Now why is this bending required? We will try to analyze. Now since this cyclist is moving in a rough road, note that there will be friction force which will provide the necessary centripetal force directed towards the center direction of the circle, and weight of the cyclist, and from the road there will be a normal contact force along the vertical direction. Now when the cyclist is going to take the turn, since friction provides a necessary centripetal force, we'll write F equal to mv square by r. Now for a moment, just imagine that the cyclist is not bending and the cycle is exactly vertical. I'll draw a diagram for that. So I have drawn it below. You can see that blue colored vertical line. Imagine that to be the cyclist not bending to the vertical. Then there will be friction force here. Weight and normal force, they are going to pass through the vertical lines. Now, if this be the case, weight and normal force, note that weight and normal force both will pass through the center of mass. So those two forces will not provide any torque about center of mass, and friction force will generate a torque which will disturb the rotational equilibrium of the cyclist, and the cyclist will not be able to take a proper turn, remaining absolutely vertical. So that's why this bending is required. And also this bending should be in such a way that, is a very interesting point, the resulting force of N and this friction force, which is static in nature, the resultant of these two forces should pass through the center of mass. Because if it doesn't pass through, suppose a resultant of N and F is passing through some other direction, not passing through the center of mass of the cyclist. So resultant, if I call it as R dash, now, if it doesn't pass through center of mass, then this R dash will contribute for torque about the center of mass, again disturbing the equilibrium, rotational equilibrium of the cyclist. So this theta angle should be in such a way that the resultant of N and this friction force should be passing through the center of mass. So that's the idea that we are going to use. The friction will be equal to mv square by r. Now resultant of N and F, now I have made a diagram on the right. So look at the cyclist over there, bent at an angle theta. So if resultant of N and F is going to be this vector, so N, F and the resultant will form a right angle triangle, and we can say from this right angle triangle, tan theta will be equal to F divided by N. So tan theta becomes F by N, and N value should be mg. Vertical direction net force must be 0. So if N equal to mg, you substitute F equal to mv square by r, you will get tan theta equal to mv square by r, or tan theta should be equal to v square by rg. So with whatever speed the cyclist is moving on the horizontal road, the angle theta should be such that tan theta should be equal to v square by rg, where r is the radius of the circle in which the cyclist is taking the turn. Right. So that circle has radius r. I made that in the diagram, in the circle diagram. So look at that. Right. R is the radius of that circle, and tan theta should be equal to v square by rg. So this much bending is required with the vertical. Now, as the speed keeps on increasing, so if the cyclist wants to take a turn with increasing values of speed, accordingly the bending angle should be more. Right. And also for no skidding, there is a condition that this friction should not exceed the limiting value. So if friction exceeds the limiting value, or in other words, mv square by r, which is friction, this must be lesser than or equal to mu times normal contact force. In this case, normal contact force is mg. So this v square should also be lesser than or equal to mu times rg, or v should be lesser than or equal to root of mu rg. So this condition on v is also required to prevent the skidding of the cyclist. So beyond this velocity, the cyclist anyway cannot take the turn, and depending on what velocity v is there, so accordingly for that velocity the bending is also required. right? So this is about bending of a cyclist on a level road, a very interesting physics behind it, why that bending is required. That bending is required to maintain the rotational equilibrium of the cyclist, and that particular person can move without any wobbles, right? So that's about this discussion.